Futurized goes beneath the trends, tracking the underlying forces of disruption in tech, policy, business models, social dynamics, and the environment. Join me, futurist Trond Arne Undheim, PhD author, investor, and serial entrepreneur, as I discuss the societal impact of deep tech such as AI, blockchain, IoT, nanotech, quantum, robotics, and synthetic biology, and tackle topics such as entrepreneurship, trends, or the future of work. I'm a research scholar in global systemic risk, innovation, and policy at Stanford University. On Futurized, I interview smart people with a soul, founders, authors, executives, and other thought leaders, or even the occasional celebrity. Futurized is a bi-weekly show preparing you to think about how to deal with the next decade's disruption so you can succeed and thrive no matter what happens. Futurized, conversations that matter. If you're new to the show, seek particular topics, or are looking for a great way to tell your friends about the show, we've got the episode categories. Those are at futurized.org/episodes. I am the co-author of Augmented Lean, a human-centric framework for managing frontline operation, and the author of Health Tech, Rebooting Society's Software, Hardware, and Mindset, Future Tech, How to Capture Value from Disruptive Industry Trends, Pandemic Aftermath, How Coronavirus Changes Global Society, Disruption Games, How to Thrive on Serial Failure, and of Leadership from Below, How the Internet Generation Redefines the Workplace. For an overview, you can go to trondundheim.com/books. At this stage, Futurized is lucky enough to have several sponsors, and to check them out, go to futurized.org/sponsors. If you're interested in sponsoring the podcast or to get an overview of other services provided by me, including how to book me for keynote speeches, please go to futurized.org/store. We'll consider all brands that have demonstrably positive contributions to the future. Before you do anything else, make sure you are subscribed to our newsletter on futurized.org, where you can find hundreds of episodes of conversations that matter to the future. Please also leave a positive review on iTunes. Thanks so much. John, welcome to the podcast. Great to have you.
Yeah, Trond, thank you. Pleasure to be here.
Yeah, John, so you're the CEO of Boston Micro Fabrication. We'll talk a bit about what you're up to, and more importantly, what's happening in this space. Miniaturization, 3D printing, the whole additive space. It's had an interesting journey, but let's talk about you first. You have a bunch of different companies under your belt. You've been in this general business, including robotics and other things in the general electronics and hardware business for a while now. Before that, you've got some degrees, engineer, I believe, from Cornell originally, and then a master's from Rensselaer and an MBA from Union College. You've sampled some universities there. John, is that what got you involved in hardware?
Yeah, so I got some engineering degrees. I still admit I was somewhat directionless as a younger man, but it was good in math and science, and got involved and went to undergraduate and graduate school. And I worked for some big companies in the early 90s. I worked for GE, for example, and some others. And actually, within a few years, I quickly realized I wasn't in love with engineering as a profession necessarily. And not sure I was very good at it either. And I sort of moved into more product management and sales roles throughout the 90s, and then also became much more interested in early stage companies.
Mm-hmm. You did tell me that you didn't necessarily yourself see the potential in 3D printing. You were not like the first one who walked into college and said miniaturization and printing things is going to change the world. You were not that early adopter.
No, I was just looking to get a degree and get a halfway decent job when I got out of college. That was the loftiness of my goals at the time. But yeah, I in some ways stumbled upon 3D printing in the late 90s. I was, and 3D printing, the first 3D printing companies, there's some companies that are still out there, 3D Systems and Stratasys, all were born around late 80s, 1990s, pretty much when I was graduating from college. But you fast forward another, 8 or 10 years, and I stumbled upon it. I was involved in a company and a bigger company that was involved in industrial materials. And part of my mandate was as a technology scout. So I would spend some time at MIT looking for things to be involved with. And I was invited by a company that was doing 3D printing of filters, industrial filters. And there was a whole consortium at MIT, which is pretty well known now, led by a guy by the name of Ellie Sachs, who had sort of this group of 3D printing companies. I had never heard of this before. So I was a mechanical engineer, but I had never designed anything in my life, had never used CAD. And I saw 3D printing, and there was a company. One of the cohorts there was, or members of the cohort, was a company called Z Corp, which was one of the early companies that sort of jumped into trying to make 3D printing more available for more engineers and designers. And I still talk about this to this day. The first time I saw it, was making a model, but it, didn't look that great. It certainly wasn't strong, and I didn't get it at all. I didn't understand, why would you ever print something like that? But I met the founder. Her name was Marina Hatsopoulos, and she was engaging and smart, and she sold me that this was interesting. So I was one of the early employees of her company at the time, of really trying to get 3D printing out there. At that stage, it was really only for design verification and development, which has proven to be, arguably still the killer app, right, for 3D printing. The fact that you have a machine in your building or in your lab, and you can get a part in your hand in a couple hours for $10.
Yeah, and that's no small thing, John, right? Because we know from industrial manufacturing that manufacturing is a whole other challenge. But if you start out on the wrong foot and you have no idea what you're actually trying to produce, if you don't go through that serious storyboarding all the way until, seeing the product, what it would look like, you might be in trouble.
Yeah. And even in the early days of selling this tool for people doing development, we thought we were brilliant and said we would go out to all these customers and say, well, how much money do you spend on prototyping and making models? And the answer from most of the customers at the time, and this is
it was zero.
It was zero, right? So that was the wrong question, because we couldn't then say, well, buy my $50,000 machine. But the result is that many customers would go further down the road in building tooling or building first articles, and then somebody would say, that's not what I want, or this didn't work, or this didn't fit. And so I often say that having an early prototype is just as valuable to tell you that it's wrong versus it's that it's right, because then and your cost at that point, the earlier you catch the mistake, the less expensive it is.
Yeah. Well, tell me a little bit about this sort of 30 plus year journey that this technology has had, because so often when we hear about emerging technology, even if it is hardware, you either hear it as the product announcements and you think, okay, now everything's going to change because, some PR person has been involved and just says, this is a game changer. But you and I know that these things take time. And over these 30 years, it seems like it's like a bit contingent use case. It's, yes, it has transformed certain things. Other things have taken much longer to pan out. Can you tell us a little bit about what the limitations and also what the advancements have been that really have now created, and we'll talk about the dollars here, but essentially the overall additive market is now enormous. We've got some numbers, additive, to take one sort of concept here, has grown to become a 20 billion market. That's enormous. That's a big market. But on the other hand, it doesn't mean that everything is being 3D printed. We're printing very few houses. We're printing,
right,
compared to what's being produced in the world. It's
1% or less.
Yeah. Tiny proportion of what's being manufactured today is being 3D printed. Yeah. So explain why that is the case, because 30 years ago, you would sort of think, well, come on, if it took you 30 years to get to 1% of the market, then this is not viable.
Yeah, the evolution of 3D printing, as I said before, was in the first 10 or 20 years, and then still even arguably today, the killer app is as a communication tool, not a manufacturing tool. The fact that you can, the way people design things today, they see it on a computer screen, or they see it on a piece of paper, or they maybe see a hologram, or there's ways to visualize, but really the best way to visualize is to actually be holding this thing in your hand, or a representative of your thing in your hand, so you can get a sense for, does it fit? Is it the right size that I want? And that, again, has been really valuable. But the technical challenge to do that, it's not that hard, right? It needs to be close to the final product, but it doesn't have to be the final product, doesn't it? And if the final product is made in metal, the prototype doesn't have to be made in metal. It could be made in plastic. So as long as you're trying to communicate and test, what most people care about in a communication tool is, I want it as fast as I possibly can. I want it just as fast as it is to look on my computer screen, which is not quite right. But if you can get it within a few hours, and if the incremental cost is a couple dollars, then it's almost immediate and it's almost free. And so that has been really valuable. But as you start to cross over into using it for manufacturing, then it really needs to be that type of metal. It really needs to be that type of plastic, and it needs to maintain those tolerances. And if you make 100,000 of them, they need to be all the same. And that has proven to be, I don't think that's in retrospect, that's not a surprise to anybody, but maybe it's proven to be more challenging. And then you got to recognize that for most of these applications, you're probably competing with the incumbent technology, whatever that is, molding or machining or stamping or casting, which has been around for much longer, and has been qualified and proven and tested, and all the standards and the textbooks are written around that process. All the materials that have been developed are around those processes. And so if you're coming in with an alternative and try to disrupt it in some way, it needs to be, as a minimum, it needs to be as good. But as good is usually not enough for people to change. It needs to be, significantly better or significantly faster. And I think that's been, the headwind, I think, in a way, for 3D, the reason why we're not 3D printing everything. It's because all those other technologies also work really well.
So let's get into miniaturization as a use case in a second. But just before that, talk to me about the materials. The challenge of 3D printing, I guess there's two things that, kind of comes to mind for me. One is obviously, what material are you able to use, and what are the costs of that material versus, another process? And then number two, the environmental aspects of it, because again, both the material choice and the manufacturing process, right, would impact the environmental impact, and that's becoming also another limiting factor for all manufacturing that we have to start thinking more seriously about. What are the aspects here for various parts of the additive chain when it comes to material choice and then sustainability?
Yeah. So on the material choice, again, you're trying to satisfy a certain application. The customers or the engineers or the company involved is usually looking to match what they're doing today. So if they're making a component and they're machining it out of stainless steel, a certain grade of stainless steel, then in a perfect world, if they're going to use a 3D printer, they want the 3D printer to be used the same type of stainless steel. And that's not easy. And so, but that's the technical sort of challenge that most people face, whether they're dealing with metals or plastic, is you're trying to be this in a perfect world, you're exactly the same material. You're the exact grade of titanium that they want to use for this application, or you can convince yourselves and the customer that, hey, it's not the exact same thing, but it acts the same. And then from a cost point of view, it's typically mainly because of volume that 3D printing and manufacturing is much lower than incumbent manufacturing. The cost of 3D printing materials are factors higher, at least today. In the long run, they'll probably be the same, but at least today. So you're dealing with, is the material technically equivalent, and can I get it at a price that's an advantage? And so it means people are making if they're going to move to that, there has to be a pretty good reason. And it has, for a lot of applications where 3D printing has been adopted as the manufacturing methods, it's been for two reasons. One is the part itself, there's real advantages to making it in 3D printing, because perhaps you can make some geometry you can't make some other way. So a good example there is in aerospace. let's say you can make a bracket that's much lighter because you can make it almost like a lattice shape, and it will be stronger and lighter, and therefore in aerospace, they'll pay anything for that. Like if you can make something 5% lighter, they're all in on that. So that's one reason. And then also if you're making low volume, custom. And the good example there is dental. So dental has been all in on 3D printing for the last 5 or more years. Because if you think about dental, every denture, every aligner, every crown, everything in dental is different. And so you're always making a quantity of one. So 3D printing is a pretty attractive alternative, in those types of markets.
Well, talking about a quality of one, I mean, there was a time when the industry hype was saying every product in the world is going to be made that way. That hasn't really panned out, has it? We still have mass production. I guess it's a bit of a disappointment, but the industrial age still continues.
Yeah. Well, it's because the a lot of these processes, these incumbent processes work really well. And oh, by the way, they're also getting better year over year over year. So it's not like the speed and the quality and the process control and all the goodness that comes with injection molding is the same as it was 20 years ago. Mm-hmm. That's also way better than it was 20 years ago. So you're chasing sort of a rising goalpost in a way in terms of being potentially disruptive to an incumbent process.
Mm-hmm. What about the business model? So, I guess that's another potential advantage if you can kind of tweak the business model and sell in a different way, I guess, subscription models, or like you said, you're selling to a customer of one potentially for some of these things, at least with the early demos and prototypes, because you're making something custom. You're making it only once or something. But what have you seen over the last 30 years? What are the business models that seem to work the best in 3D printing?
Yeah, I mean, well, there's been, the $20 billion you mentioned there, that's equipment that customers are buying. That's a large part of that is the materials that are being used. There are service centers, often called service bureaus or contract manufacturers, that people go to get their part made with 3D printing. That's hundreds of millions of dollars in terms of, that's billions of dollars in terms of, overall capacity. Mm-hmm. When 3D printing first came out 30 years ago, not too many people could afford it. It was hundreds of thousands of dollars to buy a machine. So the only people who owned one were the big companies, like Boeing and others, big automotive maybe.
Yeah.
And then a whole world of the equivalent of a machine shop got set up where you had these shops that had multiple 3D printers. And so all those business models have worked to a certain extent. And they've all served customers who want to buy machines or materials or parts. But then there's been, lots of business models around the world in terms of custom manufacturing or licensing in some ways. When you think about a custom manufacturing business, a lot of the elements there, it's not just the 3D printing part. A lot of it's the design part or the data capture. A lot of time, dental, for example, usually they're not designing your crown from scratch. They're scanning your mouth first. So then you have data and then you're working from that. So there's all these business models that have to be considered or elements of it that make up the whole business model.
So let's dive into miniaturization, which is the space that you're currently in. What is the appeal there? Because, okay, so I get that. There's a move towards a lot more smaller electronic parts. We have, a plethora of new devices. Maybe the cell phone, like you had told me earlier, maybe we're not really looking for a smaller cell phone per se, because, you need to see the screen, at least if it has like similar functionality. But many, many other things are still, trying to use Moore's law, trying to kind of go down in size. And, we're making every object around us more and more interactive and sort of capable. And we need these smaller electronic components. What is 3D printing's advantage there, and where are we with that in that space?
Yeah, so that's really that trend is really the basis of why BMF was formed. and going back a few years, is that miniaturization is happening for a lot of reasons. In medical device, doctors and medical device manufacturers would like to make surgeries less invasive, would like to make recovery times faster. Like all those things are happening. But one of the challenges when you make smaller parts is that the incumbent manufacturing processes, again, like molding, machining, stamping, they get more difficult, or as a minimum, they get more expensive. The smaller the part gets. And so a lot of our customers, and we sell our platform to big OEMs in the industries you described: medical device, electronics, optics, and photonics. They're all facing similar challenges where the demand for the application is driving that things get smaller. They used to mold this, and now they're like, I'm not sure I can mold this anymore because it's so small. So a lot of those trends are all coming together at the same time, and 3D printing is an alternative because 3D, we have a process where we can get pretty small and really hit features that are sort of in the tens of micron range, where if you wanted to mold that or machine that, either one, it'd be hard to do, or two, it would be expensive. So I'll use an example. Like, to make an injection mold for this, like my mouse, it's maybe tens of thousands of dollars. So it takes a while. It's expensive, relatively expensive. But if you wanted to make an injection mold for something that's much, much smaller, like a connector with very fine features, the mold might be $300,000. So sort of that upfront cost, because it needs to be so precise when you're machining that mold and all those features. And oh, by the way, we need two of them, because what happens if something goes wrong with the first one? So your upfront cost in manufacturing is much, much higher, depending for the manufacturing process when it gets small. But a lot of it's being driven by demand. I use another industry example in AR VR. I think AR VR, the future of AR VR is maybe uncertain, depends on who you talk to, but I think we all believe it's going to be big in some form, right? And one of the limiting factors is the goggles are too big, right? Like if you hear any negative about AR VR, it's a big part of that is, you get tired, your neck hurts, or it's too big. So we have a whole bunch of customers in that space because they're all looking to make the glasses smaller. But they still have to be able to fit in everything into those glasses: the cameras, the sensors, the lighting, and that's just a trend that's out there that maybe wasn't there, 5 years ago.
So, what then are the competitive dynamics? There are obviously several players in this space. What are you guys competing on? Is it faster to smaller, or is it price now? Is it become more of a commodity type market? Because there really are quite a few players in this space. What is the competitive dynamics?
Yeah, so additive as a whole, certainly, when I got involved with it 25 years or more, there weren't that many players, right? So we were all pretty happy growing our businesses, but it was a $1 billion market, not a $20 billion market. But today, there's pros and cons of this. There's been a lot of investment over the last 10 years. There's a lot of venture capital that has gone into this industry over the last 10 years. And the result of that is the technology has taken huge leaps forward. The machines are better, materials are better, software is better. Even for somebody who's been doing this for a long time, if you had asked me 5 years ago, could you do this, and this on a 3D printer, I would have probably been like, I don't think so. But now, those things are happening. So the benefit of this big sort of investment cycle of the last 10 years is the technologies are really interesting and really capable. The challenge a little bit is it's gotten a little bit crowded. So it has become somewhat commoditized. There's lots of vendors that are out there. Great for the customer, right?
Yeah.
As long as the customer can navigate all the choices, fantastic for the customer. But from a technology vendor point of view, it's been a little bit challenging. I'm not going to say we don't have any competition, but we're in a little bit of a niche where we're focused on very, very high precision micro components. So we don't have as many competitors, and that's great for now. That certainly, as this business evolves and becomes bigger, we would expect to have more.
Mm-hmm. So what is it that has improved incrementally when you let's just take the last sort of decade? Is it the materials that have become easier to fit into the 3D printing systems? Is it the electronics themselves that have changed characteristics? Or is it, everybody wants to talk about AI these days. Is it the integration with far more advanced sort of machine learning algorithms that's making this easier? What is driving, or is it all of it?
I think it's all of that, but also cost. There was a disruption in the market in 2010. So prior to 2010, there were 3D printers in the market, and I was involved in a company 10 years before that we thought at the time we were disruptive in terms of price point. We had something that was $50,000 or $60,000. It was way cheaper than everybody else. But starting in 2010, you could buy a 3D printer for $1,000. And there was a company in New York that started that trend called MakerBot. Their founder was a larger than life personality. He was on the cover of Wired magazine showing people that you could have a desktop 3D printer, and that was very disruptive, I think, in a positive way. Now, at the time, I was the incumbent. I was an incumbent CEO of somebody selling $50,000 machines. So certainly for the first year or two, I was like, yeah, that's garbage. It's made out of wood. Like, why would anybody want that, right? But it disrupted the market in a pretty big way. It made it accessible for students and libraries, and even individuals could have it in your home. Arguably in 2010, 2011, 2012, it wasn't that great. Like, it didn't measure up to what was there in the industrial market, but that changed over time. Certainly now you can buy a $1,000 printer or $5,000 printer that's pretty good and can do a lot of things.
How important is that tinkering aspect of this particular market? Is it do people really, even in the industrial use cases, do you find that people who are innovating now in this space are they truly bringing a printer home and kind of tinkering on their spare time, or is this still a very professional use case?
I think that was a little bit of the dream, in the early 2010 decade, that one would be in everybody's home. That proved not to be true.
Yeah. And that's because of the price points.
Well, I actually think it's because I think the people who were engineers or made things as a hobby, they bought one and they got a lot out of it. I actually think of myself. I've been in this industry for 25 plus years. I do not have a 3D printer in my home because I don't really that's not one of my hobbies. So why would I have one in my home? I do other stuff with my free time. So so the people who already had a lathe in their basement bought 3D printers, and that made complete sense. But it wasn't going to be on your kitchen counter, like to make things. That hasn't evolved yet. There was the dream. I think there was the dream that people could make anything, anytime. They could buy a replacement for their kitchen cabinet. I've never bought into that. I actually think the single biggest competitor to that idea is Amazon. I can buy anything on Amazon and get it tomorrow, right? So if you want the immediacy of something, that's available. Now, if you want the experience of going into a CAD station and designing this knob and then printing it out and, it didn't work, try it again. If you want that experience, good for you. But if you just want the knob, then you're going to buy it on Amazon. Now, these things have all evolved over time. And getting all the way back to your first question, processing power is way more than it used to be at a fraction of the price. The materials have evolved to be much more functional at a fraction of the price. Even the components that go into a 3D printer, from print heads to cameras to lasers to all the mechanical stuff that typically goes into a 3D printer, have all gotten better and better over time. And it's allowed the printers themselves as a machine to get much, much better over time.
What about the regulatory side? I mean, at some point, or on a regular basis, this security concern flares up with people being able to print weapons of various kinds, or something dangerous. And I guess now with the AI age, people would be potentially scared of anybody sort of printing something vastly more dangerous than an actual handgun. Something that truly could do mass damage. What do you think the regulatory role is in fostering this market?
Yeah, I mean, it's certainly there have been real and perceived concerns about people using 3D printers, that it's made a manufacturing tool more accessible than it might have been before. I mean, you could always make a gun on a CNC machine before, right? I mean, that's always been true.
Yeah, it's a mechanical.
But perhaps it's a bit easier with $1,000 printer. And I think the waves of concern or interest in that part of the market sort of go up and down. I think more of the regulatory push that I hear about today is when the end product itself is regulated. And I'm not talking about guns. I'm talking more probably about medical device, right? Yep. So if you're now manufacturing drug delivery devices or sensors or implants, those products are certainly regulated. But then the manufacturing method that is being used to make them also has to be regulated. So I think more and more the 3D printer companies are being asked to meet all those requirements in terms of repeatability and traceability and quality and cleanliness and all those types of things. And it's part of a natural cycle that, for regulated industries.
Let's talk a little bit about the future prospect. So, we have talked about how, 30 years is not a long time when you're trying to change an industrial process. Let's talk a bit about the shorter term future. If you just think, 3 to 5 years ahead, so the normal horizon for someone who's basically trying to do something in business, right? Next products, horizons, things that people can kind of get excited about in the near term. What do you see happening? Is there any revolutions in sight? Are there new things? This whole idea of truly distributed 3D printing, is that, you think that you lay that dead for another few decades? Or do you think something akin to that, like truly using 3D printing in mass customization, that kind of thing, distributed in people's homes or in people's neighborhoods, is any of that coming to the market?
I think the distributed manufacturing concept is powerful, and I think I'll get back to that in a sec. I think the mass customization demand, I think, is still unproven. Now, certain things have to be mass customized, like dental, right? But I think there have been other starts and stops on mass customization. Earbuds is actually a pretty good example. So there's been multiple attempts, like, customize your earbuds. I think most people don't care. That's my opinion, right? Like, I'm perfectly happy with my AirPods, and they fit in my ear, and right. Would I pay $200 more for something that really fit in my ear? I'm not sure I would, but I think some of these
depends on your ear, I guess, right? If for me, certain headphones hurt me when I use them on an airplane. So if someone could make something that was molded to my ear, maybe,
right?
But not at $1,000, no.
Right. So I think the market concept of mass customization, I think, is still a little bit up in the air. But I think the idea of distributed manufacturing, where instead of one factory in the world, you've got 20 or 50, and you can being producing in shorter lots, and then you're closer to the customer, so your carbon footprint is lower, or they can be somewhat customized. Like the product in Korea is somewhat different than the product in Florida. I think that's valuable, and I think software and because what's important in those applications is even if imagine you are printing the same thing that, across the world, that you really can print the same thing across the world on two different machines. Mm-hmm. And so that requires software being in the cloud, quality, AI to a certain extent to be, gathering information and collating information and feeding it back into the machine. So I think that idea still has legs, regardless of. I mean, there's been a lot of discussions about bringing manufacturing back to the U.S. and distributed manufacturing because of geopolitical effects. Let's forget that for a second. Just the idea of distributed manufacturing as a whole, is a positive, and I think additive can play a big role there.
What about, I guess to some people, for me, for example, printing bio-based materials, particularly new and emerging materials, right there, AI, for example, has been a big boon on this new material discovery process. So there's all of these new materials that are, a little better for the environment and have all kinds of desirable features. They were never machined the old way. They, in fact, are still in the production process. We don't really exactly know how to turn them into products. Is there a prospect that we will see materials used that have never been used in the old way that will come first on 3D printing?
Yeah, because especially in the bio world, a lot of these applications or even geometries, I'll call them, are organic in a way, mm-hmm. and not easy to make some other way. And if you can custom tailor a stent or custom tailor a drug delivery device or an implant that then would be absorbed into your body afterwards.
Right. That's the kind of thing I was thinking about.
Yeah, there's a lot going on there, and there's a lot going on there. Now, it takes a long time, right? From the time you print something to the time you think about doing clinical studies to testing to approval, it takes years, unfortunately. But that there's a lot of activity around that. We're involved in some of that. When people are looking at drug delivery devices and implants, especially when they want it to be bioresorbable. They want to put it in your body. They want to have it do the job that it's supposed to do over the course of the coming weeks. And then they don't want to have to go back in and get it, right? That it's just absorbed into your body. That I think there's a lot of merit around those ideas.
What about, I know you're an expert on the miniature side of things, but what changes when scale gets larger? Is there also a way that techniques that are used in the miniature space can be kind of 1000x and 10,000x in size because you have found some desirable features that are happening at the micro scale that you can exploit on the macro scale? Or is that two completely different? I'm thinking about industrial production, the likes of, the future of steel or the future of cement or any kind of, even the future of wood, I guess, these kinds of construction materials that are mass produced today in large sizes. Is there something happening on your micro scale that could actually be scaled up, or is it two just opposite concerns?
I think I would say it is probably two opposite ends of the spectrum, but I think what they have in common is when things get really small or things get really big, they both are hard to do conventionally, and right. So this is where additive can maybe be a nice alternative. So we've talked about in micro where we're doing some things on a small scale, but you look at other things like making a boat hull. Mm-hmm. Well, how do they do it now? They often may make a very large mold, or they are doing very very large machining, or you could 3D print it, right? Mm-hmm. So there are times when the parts get very large, and when I say very large, like larger than a car size, where it's also hard to do conventionally, or it's much more manual. I think there's been a lot of noise about 3D printing houses, and I think that will play out. I'm not, I admittedly haven't spent enough time really thinking, in my opinion, is that a good idea or not? But there's certain structures and certain applications where it will make a whole lot of sense, because most building of a house today is manual, right? You deliver all the concrete, and you deliver all the wood, and you deliver all the steel, and 10 guys build a house over the course of a month or two. But if you could eliminate that, a big part of that, with some automation, and it's not so much about 3D printing, it's automation, right? That you're using a robot in a way to take away some of that manual labor.
What are some of the more exciting emerging types of miniaturized products that you could envision your platform being used for? If someone comes to you and says, hey, I have a completely new idea for something that we're going to use in space, and it has to be small, it has to travel great distances and communicate back, or, do you have something concrete when it comes to that device that's inside your body, or like some other crazy use case? What is happening at the vanguard of this type of process?
Yeah, so I would say most of the exciting things we see, a lot of them are in medical device, where people are conceiving of. I think they fit in a couple buckets. Drug delivery devices, where things are maybe inserted in your body and then timed over time. Also, the ability to make much smaller tools. So for surgery. So if you think about, if you need a stent in your brain, one, the stent has to be small, but also the tool that they're using to put the stent in your brain, they want to make that as small as possible.
And is that integrated with robotics as well? I know you have a background in robotics.
It very much can be.
Some of these are robotic tools as well.
They can be hand or with robots. Yeah, I mean that's all happening, and so we're able to be in the front seat for a lot of those and see those. Most of them are proprietary, and we can't tell big stories about them necessarily. But it's some really interesting things in medical device. And then I think when you get into sort of optics and photonics and electronics, lenses are getting smaller, cameras are getting smaller, sensors are all getting smaller. Now, we're often not the active component, so we're not the lens or the chip, but they need the packaging around it or the array in front of it for it to really work. And so we're pretty actively involved in some of those projects.
Well, photonics has been lauded as one of the platforms of the future. Are you? Do you buy into that?
Sure. I mean, there's. It's a pretty wide range of applications. So whether it's doing measuring devices with the lights or sensors. I mean, I just bought a relatively new car. I bought a new car about a year ago, and it's not a high-end, German luxury sedan. It's a, middle-of-the-road car. But the amount of sensors in that car are way more than, my wife's luxury vehicle that she drives around that's 5 years old. Yeah. And so there's a lot of technology in there now between the sensors. But it then brings up all sorts of other engineering challenges. How are the windshields and the front of your headlights how are they going to be heated now? Because it used to be they have lines in front of them that say defrost those lines can't be there anymore if you have sensors behind it. So it changes all these other things. Now you have to have heaters that work in a different way. So more and more technology is being driven by processing power and materials, and the role that we play is that in a lot of cases these things are pretty small.
Yeah. Well, I mean, it's interesting because it's an area that captures people's attention, but of course people's attention span is short. So unless the products come out, right, you kind of lose attention. I guess it's one of these industries that will always be an industry of the future because, like you said, your main role as an industry for now is in this early stage product development. So you're actually enabling products that eventually will go mass scale, but in much earlier stages.
Yeah, and we try to stay, part of our mandate that we started the company is to try to keep an eye toward, is this process scalable from a manufacturing point of view, or at least we believe it could be within a few years, because there are sub-micron technologies and nanotechnologies that are out there that are amazing. But if you wanted to make a part, the size of a golf ball, let's say, for example, on a nanotechnology, it might take a month. And so there's a balance there between the level of, say, resolution or size you can do, and then being practical in terms of, can you imagine making 10,000 of these in a month?
Yeah, I guess that was why I was asking the question of scale, because it's so easy to get enthused by this like idea that you can make things smaller and smaller, but sometimes that's not the point, right?
Right.
You pick the size that's adaptable and right for that particular type of application, and then you just optimize within that. Look, John, this is fascinating stuff. I hope that we can stay in touch in this, and congratulations on innovating on at the microscale. That's fantastic.
Well, thanks for listening. Appreciate it.
Yeah, great. Thank you.
You have just listened to another episode of the Futurized podcast with me, Trond Arne Undheim, futurist, scholar, and author. If you are interested in my products or services, feel free to check out futurized.org/store, where you can book a keynote speech, become a sponsor or partner, request a podcast swap, or buy a few of my books, such as Augmented Lean, Health Tech, Future Tech, Pandemic Aftermath, Disruption Games, or Leadership from Below. If you're interested in any or all of my projects, check out my website, trondundheim.com, which has links to other podcasts as well as my public appearances. Thank you. Please share this show with those you care about. To find us on social media is easy. We are Futurized on LinkedIn and YouTube, and Futurized2 on Instagram and Twitter. See you next time. Futurized, conversations that matter.